So, if we're going to differentiate this one implicitly, this is where we go through term by term, take derivatives like we're used to with the same rules we're used to. It's just when we take a derivative of a y piece, that's where we add that little dy dx notation. So number 5 here, take the derivative of 2x squared to start. You get 4x. Add on derivative of 3y cubed. That'd be 9y squared. Took the derivative of y, so need a dy dx. That equals derivative of 18. That's a constant, so that goes to 0. At this point, you just identify where your dy dx's are at, see what is attached to those dy dx's through multiplication, get all those dy dx's on one side, get anything else on the other. So here, pretty straightforward. You've just got the one term, really, that's got the dy dx in it. That stays on the left side. I'm going to move that 4x over to the right side, so subtract it over. And then, since we just have the single term of dy dx, divide 9y squared over. dy dx is going to equal negative 4x over 9y squared. Number 6, same idea. Start with the x to the 4th, derivative of x to the 4th, 4x cubed. Plus, got a 2x times a y here. It's a product. So you see that little xy combination, two variables, got to use the product rule. As far as the 2 is concerned, just let the 2 be attached to the x as the first piece. Following your product rule, you take the derivative of 2x to start, you get 2. You multiply that to y. You add on, first piece unchanged, so that's 2x, times derivative of that second piece, so derivative of y would be 1. You took the derivative of y, so you need a dy dx. Okay, continuing further, you got this minus 4y to the second. Take that derivative there. That's going to be negative 8y. Took a derivative of y, so need the dy dx label. And finally, that equals 0, because that's the derivative of 10. Locate your dy dx's. See what is attached to those dy dx's through multiplication. Got the 2 terms here. We're going to isolate those terms on one side. We're going to move everything else over to the other side. So everything else would include the 4x cubed, subtract that over, and the 2y, subtract that over. We do this because at this stage we are factoring out a dy dx. We're taking what's left over, dividing that over to the other side, so dy dx is going to equal negative 4x cubed minus 2y all over 2x minus 8y. All right, with this trig scenario, we've got an expression that starts here of x times the sine of y. So we see the variable in front of the trig function. That means it's being multiplied onto the trig function. This variable right here of y, that's part of the sine function itself. So we got a product rule of x times sine of y. We start with that product rule. Take your derivative of the first piece, x, get 1. Multiply to the second piece, sine of y. Add on. First piece unchanged, x, times derivative of that second piece. Derivative of the sine of y would be cosine of y. And remember, cosine takes care of the sine part, but now you got to take the derivative of that piece that follows. That piece that follows is a y, so you're going to have 1 as that derivative, dy dx. Okay, now moving on, we are subtracting derivative for the cosine of y. Well, starting with the cosine part, derivative of cosine is negative sine. Since we're subtracting here, I'll make that plus sign. And much like we did over here, it's going to be sine of y with a dy dx. Since in the original equation this equals 12, derivative over here of 12 is going to be 0. All right, highlight those dy dx's again. We got a dy dx here attached to that sine of y through multiplication. We got a dy dx here attached to x times the cosine of y through multiplication. Let's keep these underlined pieces on one side. And let's move over that sine of y to the other side, so subtract it over. Since we're just reviewing here, right, at this point we're factoring out the dy dx. Remember, this step I'm showing you, the one we're currently on, this is an optional step. If you know how to go from what you have up here down to the final answer, I get it, that's fine, go there. If you need to see the step, you need to do the factoring, by all means do it. dy dx is going to equal the negative sine y that we have on the right side divided by all these leftovers here. So x cosine of y plus sine of y. Okay, number 8, we got a lot of rules going on here. We start with the chain rule. We start with this quantity to the power of 2, so we bring down the 2. Quantity stays as is. New power would be 1. Continue with the chain though. Tack on the derivative of the inside. Well, inside we got an x cubed, so that derivative is 3x squared. We're adding on, inside we got a y squared, so 2y dy dx. That's the chain rule for this piece. But we add on, here's that product rule again. We got that xy combination, so 3x times y is how we'll treat the product. Take the derivative, excuse me, of 3x, get 3, times second piece y, plus first piece 3x, times derivative of the second piece is y, so that's 1 dy dx. That all equals derivative of 6, which is 0. Okay, this is where you have to be careful now, locating these dy dx's. Remember, you're looking to see what's lumped together with the dy dx through multiplication. This right here, that's its own term. But as I look at this dy dx, I recognize it's trapped inside parentheses, which means there's something in front of the parentheses that is technically being multiplied to that. So we need to take this part that's in front and distribute it through. Before I start shuffling from side to side, got to multiply this out. So when you multiply it out, you got the 2x cubed plus y squared that's being multiplied through first to a 3x squared. But then second, as we add on here, we're taking that 2x cubed plus y to the second, and we're multiplying to the second piece here, which is a 2y dy dx. There's that distribution. We bring along the other pieces. We got a 3y, we got a 3x dy dx. All right, now we're ready to see what's multiplied to these dy dx's. So once again, this term right here, 3x dy dx, we know that goes together. But where we see this other dy dx, everything that's multiplied to it would be all of that. So I know I'm going to keep these underlying pieces on one side, and I'm going to move everything else to the other side. I talked about that optional step on the previous problem. Let's see if we can cut to the chase here. dy dx is going to equal. Okay, we know it's going to equal this fun-looking fraction over here, where on top it's going to be the pieces that we moved over. So subtract 3y over, right? Subtract this big mess. Okay? And then on the left side, we would have had these underlined pieces where we would have factored out a dy dx, right? And we would have taken the leftovers, divided them over. So if we take a dy dx out of this entire mess, that would be divided over. And then we would have been adding on, got this dy dx we would have taken out, so 3x. There's your dy dx with one less step.